Hi you guys, this is just a quick tutorial on how to do calculations for your yeast and Elodea slides from your color lab today. So these are all just pretend numbers, so please use your own numbers for some of the measurements here, because again, I don't have a notebook in front of me, I don't have a ruler in front of me, so I'm just making these up as I go. So remember, you guys should have 4 drawings of the yeast, 2 unstained, 2 stained, both in numerical aperture 0.1 and 0.5, and then 2 pictures of Elodea, one at 0.5 and 0.1 also, so you have 6 pictures total, right? The lab only wants you to calculate 1 yeast cell, right? And assuming you drew them all about the same, the numbers should all be about the same. The Elodea one's going to be a little bit different. So let me go ahead and jump in here. So this is something that I would have in my notebook. Remember, there are things that you need on there. You've got your detailed drawing, the name of your specimen, you got your total magnification, you got your scale bar, you got your recommended scale bar value, and then you have your observations right there, right? Qualitative and quantitative for both of them. So what you're gonna do is this is using your notebook, right? Your notebook, whatever you drew on there, you're gonna take a ruler, and you're gonna use the centimeter side because that's the metric unit for length, and then you're going to measure something. Right now, if you have like a giant clump like this one, it says you need 1 yeast cell, and that is a clump. So you would want to pick like one of these where they're by themselves, right? And you just have to pick one. So I'm gonna pretend like I'm picking this one, and I'm just gonna use a different color so you guys can see what I'm looking at. So I'm pretending that I measured this yeast cell, and let's say I got 2 centimeters. So I'm just going to write it off here to the side so we can show our work on the bottom. If you drew yourself at 2 centimeters, you drew it too big. So it needs to be less than that. And again, this is just sample. So please make sure you're using your numbers, right? So I'm going to write an equation down on the bottom just to help guide you guys a little bit. So this one, the numerator should be actual size of specimen, so that's using your ruler and your notebook, divided by the actual size of the scale bar, right? So actual size of specimen is going to be this one that we got, so that's going to be 2 centimeters. The actual size of your scale bar, it's however long this is. This is not an arbitrary line, right? Hopefully your lab instructor and you guys did the calculations last week. That's the one, it's the same table, the FOV table from the week before, right? This is where I'm getting this information, but you should have calculated the length of line, which at this magnification should have been 1.3 centimeters. If you don't know what I'm talking about, please touch base with your lab instructor so that they can show you where these numbers are coming from. Right, so then let me grab my calculator, and I can go ahead and divide these two. So 2 divided by 1.3 centimeters is going to be 2.6, right? 2.6, and the units will actually cancel because we don't need that for later. So I'm going to scooch it down this way so we can continue. All right, so 2.6, and then you're going to multiply it by the recommended scale bar value. That's going to be this one, which again, you get that from the FOV table from the microscopy lab, right? So I'm going to multiply it by 100 micrometers, right? So let me just do it in my calculator. So 2.6 times 100, I got 260. Right, 260, and then we're just gonna take this unit right here because that's the one that we're using. So the yeast cell that I measured is 263 micrometers right there. So if it's big enough, you can stick it right below it like this, or if you don't have enough space, then just draw an arrow, right, and then just label 263 microliters. Sorry, micrometers, not liters. So that's how you do that one. right? Now for the other one, it says that you needed 5 Elodea cells. So this is the same one. You have your name, total magnification, scale bar value, qualitative, quantitative observations on here, right? And this one, it's asking you guys to have a average of 4 Elodea cells. So let me just double check, but I'm pretty sure it said 4 Elodea cells. 1 second. But when you're picking your plant cells, you guys, try to pick the ones that have a complete like rectangle and their complete box, because like something like this, for example, I'll show you. Something like this, like that's not very accurate, right? Even something like this, that's too small. So you want to pick like these ones right here where you can see all 4 corners, right? All 4 corners, as much as possible. Now, that's not always going to be easy, and that's why we're taking an average, because some of the cells might not be complete, right? They might not be complete. So you want to pick the ones as much as possible that are full, right? A full rectangle or a full square. If you can't really find that much, then again, just do your best. That's why we're taking an average. So same thing, right? And there's really 2 different ways to do this. I'm just going to show you the easiest one that I think would work out for everybody. So same thing, you're going to use a ruler, you're going to use the centimeters, and then you're going to pick your 4 and measure them, right? And measure them. So I'm just, again, making up these numbers, so please make sure that you use your numbers. So let's say that I measured this one, and this one was 3 centimeters, right? I measured this one, it was 3.6 centimeters. I measured this one's a little shorter, maybe 2.7 centimeters. And then let's say I measured this one and it was 2.5 centimeters, right? I probably, here, let me scooch these because I need to take their average. So I'm going to scooch it down here. Hopefully you know how to take an average. If you don't remember, you add all of them together and divide by the however many there are, which is 4, right? So 3 plus 3.6 plus 2.7 plus 2.5, I get 11.8, and then I divide by 4, right? Divide by 4, and I get 2.95. This is centimeters. So then you're going to use the same equation, this same equation right here, this one, that's ugly, this one, and then this piece right here, right? So you're going to put all of those together. So measured, actual measurement of the specimen is going to be your 2.95 centimeters, right? Divided by the length of scale bar, which again, if you're using the circle template, it's always going to be 1.3 centimeters, right? If you want to fast track everything, just multiply straight by 100 micrometers, because that's this one right here, right? These units cancel. We're going to be left with micrometers at the end. So let me do my math here on the calculator. 2.95 divided by 1.3 times 100. So the actual size, right? The actual size of this, of the average, sorry, of the Elodea cell is 226.9 micrometers, right? And that would be the average, right? Average length of an Elodea cell. Right, and that's how you do that. If you guys have any questions, please reach out to your lab instructor or watch the video again, but please make sure you're using your numbers, right? Everybody has about the same, similar like ranges, but you need to know how to use the equation, right? You need to know how to use the equation one more time. So it's right here. Let me write it one more time for those of you guys that need it. So this is where I'm going to label it equation to calculate actual size of specimen, right? So this is how big it actually is. So actual size of specimen, this is from your drawing, divided by actual size of scale bar, right, which was from your FOV table times the scale bar, recommended scale bar value. Recommended scale bar value, which is also in your FOV table. Right, there you go. If you have any questions, again, please reach out to your lab instructor, and I'll see you guys next time.